Hi everybody, my name is Rupa, working as Assistant Professor in Chevron Engineering College in the Department of Electrical and Electronics Engineering. I am dealing the subject renewable energy sources and today's topic is problems on tidal energy. So this is the previous problem we are gone. So a tidal power plant of simple basin of type area is given 30 into 10 power 6 meters square. Directly it is given as meter square and high range is 12 meters and low range is 3 meters. And the filling capacity, find the energy calculated in one filling emptying process. Okay, so they asked to find out the energy, how much it is needed for filling or for emptying, and the efficiency is given as 0.73. so work done range is here R to R, maximum to minimum dW. See here, we know that formula work done is equal to capital R to small r, maximum range to small range, minus G rho AH dH. Here if you integrate this h, you will get 1 by 2 G rho A R square minus R square. And average power, we know that P average is equal to work done by time. So work done, it is the work done formula we get is 1 by 2 G rho A R square minus R square and 2 into time. Okay, here time is taken as, it is given as, see the previous sum we had to calculate that 22,000, that is the constant time 22,350. So W by 2, for we are calculating for 6 hours 12.5 minutes. So if you convert that 6 hours 12.5 minutes, we will get 22,350 seconds. So that 350 seconds when multiplied by 2 here, in work done 1 by 2 comes here in denominator. So 2 into 22,350, it becomes 44,700. This is the P average. Now we will substitute the required values of the formula. Here the average power generated is 1 by 44,700 into G is 9.80. It is a constant one and rho is also a constant one, 1025 into area is given as 30 into 10 power 6. And maximum is, height is 12 and minimum is 3. If you substitute all the values, you will get 911.25 into 10 power 6 watts. If you want to convert into kilowatts, divided by 1000, you can put kilo here. So you will get 3280.5 into 10 power 6 kilowatt hours. So this is the average power generated, and now we have to calculate the generator efficiency. We have to consider the generator efficiency and calculate the energy generated. So efficiency is given as 0.73. Now multiply this with efficiency, will get the energy generated with the given efficiency. So 3280.5 to 10 power 6 into 0.78, it becomes 2395 into 10 power 6 kilowatt hours. So these are the direct formulas, no need of any indirectly calculating the values. Those are direct formulas. So this is all about the tidal systems. Okay. And this is up to storage. Now we see some advantages and limitations of tidal power generation. So what are the advantages and what are the disadvantages of tidal power generation? Now we will go through. We are going to the advantages. First advantage is, it is the biggest advantage of the tidal power. It is inexhaustible. Okay, and it is completely independent of the rain and its uncertainty also. Okay, and even a continuous dry spell of any number of years will have no effect. Okay, we have no effect on the rainfall. So if you do not have rainfall for some in some years also, we have tides. Tides do exist. So it is inexhaustible and it is completely independent of any uncertainties. Okay, and second one is pollution free. So this tidal generation, power generation, it is free from pollution and it does not use any fuel, and does not, if it does not use any fuel means it does not produce any unhealthy waste such as gases, ash and atomic refuse like that. So if it is not using any fuel, outcome, the waste will not be emitted. Okay, and third advantage is the large land is not required. So these power plants do not require or do not demand large areas of valuable land because they are on the base or seashores. Okay, so we are not supposed to buy any land, or we are not supposed to search for any site for this tidal power plant. So they can be constructed on the bay or seashores. And the last one is peak power combination with hydraulic and thermal systems. It will be proved to be effective. Okay, so when the peak demand, power demand will be occurring, if you combined this tidal power plant with the other sources of renewable energy such as thermal or hydraulic systems, it works effective. And now these are the advantages of the tidal power plant, and now we will see the limitations. Limitations are, first one is variable output. Okay, so there are number of reasons why tidal power generation is still a novelty, because it is not user as competitive to the thermal or some hydraulic systems. It is still backlogged because of these limitations, because these limitations are quite to be considered. First one is variable output. The fundamental drawback to all the methods of generating tidal power, it is the variability in output. If this variability in output will be caused by the variations of the tidal ranges. At full moon and at new moon, these will be high, and at no moons, this will be quadrature, and third quadratures moons, these will be low. So there will be some variable possibilities of types, so we can get the output also variable in nature. Second one is turbines have high head variations. These turbines have high head variations. That means the tidal ranges is highly variable, right? And turbines will also have to work with this range of head variations also. Okay, so this affects the efficiency of the plant. If there is a smooth running of the turbine, the output will also be smooth, right? So this variability affects the efficiency of the plant, as the turbine's efficiency will also be decreasing. And third one is intermittent operation. Okay, so that means that since the tidal power generation, it depends upon the level difference in the sea and the inland basin, it has an intermittent operation. That means it has a medium operation, not high and not low. Okay, so and this is feasible, that is only accessible only at certain stage of tidal cycle only. So this intermediate pattern will be improved to some extent if you multiply the basins, and if you go for a double cycle system, this intermittent operation limitation can be overcome. And fourth one is time of occurrence will be changing. Okay, so we know that tidal range is limited to a few meters. Okay, so thus if you take a bulk turbine type, this technology was not well developed. So we are using a conventional Kaplan turbines. These runners were only alternatives. That is, this is found to be unsuitable. Okay, so if you now in the present days, if you use the development which is done in the development of reversible flow bulk turbines, this difficulty can be overcome. Okay, next fifth problem is corrosion problems. Okay, so seawater is corrosive. It is containing salt, so if salt is present, corrosion problem occurs. So it can be corroded, the machinery can be get corroded. Okay, so for overcoming this disadvantage, we have to use stainless steel with high chromium content, and we can use a small amount of molybdenum and aluminum bronzes also. So these will be good corrosion resistance methods. So the project in La Rance project, we discussed it before, windmills like that. This is a La Rance project also. This also uses this type of steel, stainless steel, and with high chromium contents and amount of molybdenum aluminum bronzes will be used in this La Rance project. And vinyl paint also gives good results. And next one is construction is difficult. So normally any construction done on the land will be easy because it will not oscillate and it will be steady, and we can on a rugged surface we can construct them easily. But coming to the sea here, we are always obstructing by the sea water. So here construction in the sea or in estuaries is found difficult as the base will not be strong enough to withstand. And first we have to withstand the base, and after that we have to go further. So construction is somewhat difficult when compared to land. And eighth one is cost is not favorable. Okay, so compared to other sources of energy, when we compare to other sources of energy, the cost will be more for this tidal power plants. Okay, and next one is it is feathered hampers fishing and navigation. That is, it is feathered that tidal power plant would hamper the other natural uses of estuaries such as fishing and navigation. It gives a blocking type work. It blocks the work of remaining other navigations what are done on the seashore or base. Okay, and apart from this, there is one limitation. The duration of the power cycle is reasonably constant, but the time of occurrence the time of occurrence will be changing. Okay, so this makes that difficult for planning of load sharing every day in the grid. So this tidal power plant, due to the variations, we don't know how much power you are getting as output. Okay, so every day and every time to time we have to move this grid, we have to share the load in the grid. Okay, so this can be removed if you use computerized programs. Okay, these are the limitations of the tidal power plant. And what are the prospects of tidal energy in India, we will see now in a table. See, these are the prospects of tidal energy in India. Actually, the possible sites for tidal energy in India are obviously those where we get high tidal ranges, right? So, an example at the Gulf of Cambay, Bhavnagar, Sonara, and Gulf of Kutch, Kandla, Navalakshi, and of Howli River. Okay, so these are the places where we get high tidal ranges, and the maximum tidal range will be at the Gulf of Cambay. It is along 10.8 meters of tidal range we are getting here. See, if you see the table, we are getting 10.8. It is the highest range of tide, and it is attractive for tidal plants. We can definitely situate a we can No, undoubtedly situate a tidal power plant for the power generation. And there are two possibility sites on the western bank, namely Sonarai Creek and Bhavnagar Creek, which have an essential requirements for locating plants. These also, in these areas also we can locate a plant. But a slight change of the Gulf of Cambay is about 5000 ppm, which is to be high and needs closer for the study for the future development. Okay, and at the Gulf of Kutch, the maximum spring tide is at a range of 7.5. At Gulf of Kutch, it is 7.5. And the site changes here. The slit changes here in the Navalakshi. In the Gulf of Kutch, it is much lower than 110 ppm, nothing but potential per month. Okay, next. And the tidal ranges, see here we can see different tidal ranges here: Sagar, Diamond Harbour, Gulf of Cambay, and Gulf of Kutch. These are the assumed areas, and this is the total maximum potential area per year, and these are all using single basins. And for each basin we are getting this kV or MV. And how many basins? Two basins, alternatively operating and cooperatively operating, combinedly and alternatively. So there are at present no indications regarding the cost of generation of the tidal power plant. And after some studies we can go through them. At the Gulf of Cambay, it indicates that the higher cost of generation from the conventional sources at the Gulf of Cambay. However, the cost of coal and other allied materials is increasing also here. So this data will have to be collected for realistic assessment of, if you want to situate any tidal power plant, we have to collect this data. Okay, so these are the tidal energies in India, and this is the tidal power plant, and how the tides are used for generation of power we discussed through. So this is tidal energy. Next, in this chapter we are having a second type of energy, wave energy. Okay, so these waves we are grasping from the ocean, so that's why this is called as a ocean wave. Okay, so we know that oceans have waves, so these waves also can be used for the generation of power and different applications also. So oceans and seas waves are by wind and OTEC. Okay, so these oceans and sea waves are caused indirectly by solar energy like wind and OTEC. OTEC means ocean thermal energy conversion. Okay, so these are the ocean sources of energy. OTEC means this is the ocean, broadly ocean source of energy. So what are the ocean sources of energy means OTEC and tidal energy are the ocean sources of energy. So one of them is OTEC. OTEC means ocean thermal energy conversion. Okay, so wave energy will be derived from the wind energy, which will be derived in turn from the solar energy. Okay, so this wind energy is caused by what causes wind energy? The uneven solar heating and subsequent cooling of the earth crust and the rotation of the earth. So these three causes the wind energy. Okay, so what are the three causes of wind energy? First one is uneven solar heating, and subsequent, again after heating, the subsequent cooling of the earth crust and the rotation of the earth. These all gives wind energy. So the wave energy at its most active, it can be much concentrated than the solar energy. So devices that convert energy from waves and they produce much higher power densities than the solar devices. If you concentrate on the wave energy, this can produce more energy than the solar energy. Okay, so this will be located in the oceans. The power in the ocean waves has been part of the human experience. We know for thousands of years it is a part of a human experience. So history of atoms are done to exploit, to grasp, to extract this power from the oceans for human purposes. So it was that in recent energy crisis is there. So this energy crisis has prompted serious attempts at the harnessing of the waves for the production of electricity. So during the decade of 1970s, dozens of patents would be filed to do this. Okay, around 1970s, more patents are filed against this. Sorry, according to this. Okay, so we know that these are most complicated and rather fragile in the face of the gigantic power of the ocean storms. So these are more complicated as it is associated with the oceans. So all the patents are issued on a variety of devices, and many schemes have been described conceptually also. Some small scale prototype devices are tested. Up to now, major development program has been carried out in any country. Small devices are available. However, and in limited use of power supplies for BIOS or some navigational aids, these are used as a small devices. So for the engineering development point of view, waves energy's development is not nearly as far as long the wind and tidal energy. Okay, so in engineering development, it is not developed so much as the wind and tidal energy. Okay, so world sites have been suitable for harvesting the energy of the waves from Molokai and Alinuhaha channels in the Hawaiian Islands. Okay, so here we get 2 to 3 meters high waves during the normal trade wind periods. And there is also other place, Pacific coast of North America, the Arabian Sea of the India and Pakistan, and North Atlantic coast of Scotland and coast of New England, etc. These are also other normal trade winds we can see here. Okay, this is the introduction of the ocean wave, and now we will see what are the advantages and what are the disadvantages. First, go through the advantages. The first advantage is accumulated over time and space and transported. So this wave energy has an advantage over wind or solar. Okay, so because this energy is naturally concentrated by accumulation over time and space and transported from point to which where it is originally present in the wind. Okay, so at that one place where wind will be generated and it is transported to the other place for the extracting of power. Okay, and second one is degree of power is quite, that means that the degree of power concentration affected by the waves is quite substantially where the power density in wind may not be. Okay, the power concentration will be high. That means at a good site, suppose we take a good site, average some hundreds of watts per square meter wave is being transported across a plane perpendicular to the wave propagation direction at a good site. Okay, always wave will be traveling perpendicular to the oceans. Okay, and a good site, at a good site, the wave will be 10 to 100 times large. Okay, next, Next advantage is free and renewable energy or sources. So it is free and renewable energy source. And next one is low land masses. Wave power devices do not use up large land masses. Okay, so suppose if you compare this with the solar or wind, these uses large land masses, and this is not the thing required in the wave power devices. And the last one is pollution free. So almost it is a zero pollution. It is getting zero pollution. So these devices are relatively pollution free, and because they remove energy from the waves, they leave just water. Okay, so they leave just water as a waste. So water is not a pollutant. So this can be termed as a pollution free. Next, coming to the disadvantages or limitations. The major disadvantage of wave energies as compared to wind is that first one, the energy is available. Energy extraction is difficult because this energy is available in the ocean. The extraction equipment must be operated in the marine environment. Okay, so we have this has to withstand all the implies in the terms of maintenance, construction cost, lifetime, and reliability. Okay, so this has to become all the problems in the ocean, all the difficulties that is concerned with the ocean. So this energy may have to be transported to greater distances to the shores. So this is one of the limitations. Next, second one is converters has to withstand severe storms. So as this is it is constructed in the oceans, the waves energy converters must be capable of withstanding very severe peak stresses in the storms. And third one is possibility of large waves. So this is a relatively scarcity of the sites, accessible sites which are having large wave activity. Okay, so the construction also has to withstand these large waves. And fourth one is complicated. Yes, it is complicated because it is constructed in the oceans. So wave energy conversion devices that has to be proposed also should be complicated. And the last one is coming to the economic factors. It is unpredictable. We don't know how much energy we will get. So we cannot predict also. So economic factors such as capital investment and cost of the maintenance, repair and replacement, as well as problems of biological growth of marine organisms, all are relatively unknown. These all are unpredictable and seem to be large side also. Okay, so these are the limitations of the wave energy. Next, what is the energy produced from the waves we see? So these are, there are two-dimensional progressive waves as shown in the figure. See here, two-dimensional progressive waves. Progressive means they are goes on and they will not stop. Progressive, that is called as progressive. Okay, so here we see two-dimensional progressive waves. These are represented by a sinusoidal simple harmonic wave shown at time t is equal to 0 and t is equal to sometime t is equal to at time t. Okay, 0 and t, that's all. Okay, and the wave may be represented by the following relation involving some parameters. See here, how can we represent this wave? Y is equal to a into sine 2 pi by lambda x minus 2 pi by tau into t, where here what are the terms we will see now. This representation, this equation 1, first one is y. This is the height above its mean level in meters. Okay, y is the height above its mean level in meters. Next, alpha is the sorry, A is the amplitude in meters. All will be in meters only. Okay, only tau will be in seconds. And lambda is the, we know that lambda, what is the lambda? Wavelength. Wavelength in meters. And T is the time. And tau is the period in seconds. This is the period in seconds. Okay, so now 2 pi is equal to, we can write x by lambda minus t by tau. Okay, so we can write here, see, I can write 2 pi is equal to, from this equation I can write 2 pi is equal to x by lambda minus t by tau. Okay, so this 2 pi here, it is represented as phase angle, and this is dimensionless. Okay, so the relationship between the wavelength and the period is approximately, we can write lambda is equal to 1.56 tau square. Okay, and this first expression, it can be expressed as y is equal to a into sine mx minus nt, where m represents 2 pi by lambda and n represents 2 pi by tau. So 2 pi by tau is called as phase rate. Okay, if you take 2a instead of a, 2a, it is the height from crest to trough. Okay, so these are the formulas we have to see, first one and second one, third one. Next, now we will see the potential energies and kinetic energies of this wave. So first, calculate the potential energy. Okay, so see this potential energy, this is arriving from the elevation of water above the mean level, that is from y is equal to 0. So if you consider a differential volume y into dx, we will have a mean height of lambda by 2. So from this we can write the potential energy is equal to dPe is equal to mzy by 2. So this can be written as rho y dx into L into zy. So m can be written as rho y dx L into zy by 2. So if you multiply all here, g rho y square, 2 y's are there, L into dx by 2. So assuming this as third equation. So if you combine these two equations, second and third. So here now we will see first we will see the abbreviations here. What is m here? It is the mass of the liquid, that is equal to y into dx per kgs. And g is the gravitational constant and rho is the water density 1025 kgs per meter cube, and g is 9.80 gravitational. And L, capital L here, it is the arbitrary width of two-dimensional waves which are perpendicular to the direction or wave propagations x. Okay, and if you combine these are the abbreviations, and if you combine these 2 and 3 equations, second equation is this one and third equation is this one. If you combine both, what we will get? PE is equal to rho L, okay, rho L a square g by 2 integrations from 0 to lambda sine square mx minus nt dx. Okay, so here if you integrate, see, these are the constant terms and we can put aside. So here if you do this integration, 1 by 2 mx minus 1 by 4 2 sine mx. Okay, so we are applying the limit 0 to lambda here. So 2 to 1 by 2 will be becoming common. we can take common 1 by 2. So 1 by 2, 1 by 2, 1 by 4. So 0 a square L, and from this we will get 0, total will be 0, and from this we will get lambda. So lambda, this is the fourth equation. Okay, so finally we can write that potential energy density per unit area, that is PE per unit area A is equal to 1 by 4 G rho alpha square. So where we know that A is equal to lambda L. So in place of lambda L, I can put capital A. In place of lambda L, I can put capital A. So if I shift the capital A to the left side term, it becomes denominator PE by A. So PE by A is equal to remaining term 1 by 4 G rho A square. Okay, next coming to the kinetic energy. Okay, so the derivation of kinetic energy is rather complex and it is beyond the scope of the book also. So from hydrodynamic theories, this can be expressed as Ke is equal to 1 by 4 G rho alpha square. Alpha square lambda L. Sorry, A square. This is not alpha square. A square lambda L. Okay. Here A is amplitude. And lambda L again I can write as A, area of per unit area I can write. So if A becomes denominator of Ke by A is equal to remaining term 1 by 4 G rho A square. Okay, so the total, this is the kinetic energy density, and the total energy and power density can be written as E by A is equal to half of the G rho alpha square. Okay, so that means that P by A is equal to half, P is equal to power, energy into efficiency. The power is equal to formula. What is the formula for power? P is equal to efficiency or frequency. Power is equal to energy into frequency. So in place of E, I can write P by F. Okay, so if if I send this F to the right hand side, the formula will become P by A is equal to half G rho A square into F. So we know that F is the frequency, E is the energy, and P is the power here. Okay, so these are the direct formulas used in the problems. We can directly use the kinetic density formula and total energy and power density formula, this one. If it is in the terms of frequency, we use this one. If it is in the terms of just G rho A square area and amplitude terms, we use this one. Okay, so next we will go to wave energy conversion devices. What are the devices used for the wave energy conversion? There are different types of conversions, converting machines discussed. So we will discuss in next class.